Section 4.5, Inequalities involving quadratic functions. There is a slight chance you might hear some background effects this time again. The kids are playing in the toy room, which is a little ways away. Sometimes they get a little loud. But inequalities involving quadratic functions. Just to review again, a quadratic function is in form ax squared plus bx plus c. That's what a quadratic function is. It has an axis of symmetry, and it either opens up or it opens down. So if we look at just a graph to start off with, we have an example of a quadratic function, and we're determining the intervals where g of x, or where this function is less than 0. This function is going to be less than 0 wherever the outputs are less than 0. Well, the outputs, they are all going to be less than 0 wherever it's below the x-axis. So where this is below x-axis, because wherever it's below the x-axis, that's where the y values or the outputs are below 0. And it's greater than or equal to 0 wherever it is above the x-axis, because that is where all the y values or the outputs are greater than or equal to 0. So looking at this graph, g of x is less than 0 on this part right here, which are all the x values that start from negative infinity up to negative 1, or I use that u again for or, on the interval over here, from everything from 4, and it just keeps on going to infinity. Those are where the x values make this function less than 0. Where it's above the x-axis, or where it's greater than or equal to 0, is this interval right here. So all these y values, all these outputs are greater than 0, and that happens when the x's are between negative 1 and 4. Looking at it graphically. So let's suppose we don't have the graph and we needed to solve this inequality where x squared plus 3x minus 10 is greater than 0. Well, what I can do, I can first solve for where it's actually equal to 0. And if I solve for where it's equal to 0, I'd solve for, see if I can factor it. I see a x plus 5 and an x minus 2. Where it's equal to 0, because those are going to be my boundaries or my cutoff points, where it's equal to 0. So either x plus 5 is equal to 0, or x minus 2 is equal to 0, meaning x is either negative 5 or x is equal to 2. That's where this function or this equation is going to equal 0, have an output of 0. So I know on the graph that at negative 5, 1, 2, 3, 4, 5, that point right there, and 2, that this function is going to have an output of 0. Well, what does this function actually look like? This is a parabola. There's a positive 1 in front of the x squared, so it's going to open up. If it opens up and it passes through those points, it's going to look something like that. Where is this greater than 0? Where all the outputs are bigger than 0, so in that interval and that interval, just like that. And those intervals, here we have negative 5 and positive 2. Those intervals are from negative infinity all the way from the left up to negative 5 for x inputs, or skip over this where it's less than 0, the interval from 2 to positive infinity, like that. Doing another one, this one's not actually equal to 0. We're looking for where x squared plus 7x minus 5 is equal to, or is less than negative 5. X squared plus 7x is less than negative 5. This is equivalent to saying, where is x squared plus 7x plus 5 less than 0 if we add 5 to both sides? Well, when I do that, I would do the same thing. I would solve again for where it's equal to 0. Where it's equal to 0, I'm going to check to see if I can factor this here. I don't think I can factor it, so I can either solve it by completing the square or using the quadratic. If I use the quadratic, the negative b plus or minus the square root of b squared minus 4ac all over 2a. I'm going to get x's, or zeros, where it's negative 7 plus or minus the square root. B squared is 7 squared, so 49 minus 4 times 1 times a times c times 5 all over 2 times a, or 2 times 1. Do a little bit of simplification. Negative 7 plus or minus the square root of 49 minus 20 here, or 29 over 2, which I get my two answers where this is 0 at negative 7 minus square root of 29 over 2 and negative 7 plus square root of 29 over 2. On a graph, those are the two zeros. So if I look at this one, negative 7 plus the square root of 29, square root of 29 is about the square root of 25. So this is going to be about 5. Negative 7 plus about 5 is about negative 2, divided by 2 is negative 1. So that point is right about there, and then the other point. So we have negative 7 minus the square root of 29 over 2, and negative 7 plus square root of 29 over 2. Those 2 points. If I look here, this equation is a parabola that points up because it's got a positive in front of there. So it's going to cross through those two zeros, go down, come back up. This is less than 0 in this interval right there. Those are all the outputs that are less than 0. That interval happens from negative 7 minus the square root of 29 over 2 up to negative 7 plus square root of 29 over 2. And there I have my solution set. Solve this inequality. X squared plus x is less than or equal to 2. I'll get it equal to 0 first, so it's less than or equal to 0, so that I can solve for when this is equal to 0. Here I see I can factor this. X plus 2 times x minus 1. Where's that less than or equal to 0? I solve for where it's equal to 0, so x plus 2 equals 0, x minus 1 equals 0, and so we get x equals negative 2 and x equals 1, like that. So those 2 points are where this equation here is going to be equal to 0, which is going to be equivalent to saying where this is going to be 2, but it's where this is equal to 0. So graphically, at negative 2 and at 1, this graph is 0. It's positive, it's pointing up because there's a positive in there, like that. Where is this less than or equal to 0? Well, it's in this range right here, which is on the interval. This time, negative 2 can be included. That can be included because of the less than or equal to, up to 1, like that, would be the solution. If I wanted to double check it, to make sure I'm using the right interval, I'm going to pick a number like 0. I'm going to put 0 in and see if it holds true. Is 0 squared plus 0 less than or equal to 2? Well, yes, because 0 is less than or equal to 2. So I did have the right inequality there, or the right interval. So taking two different functions, negative x squared plus 3 and negative 3x plus 3, we're going to do a bunch of different things with those functions. This should really be question 1, question 2, question 3, and question 4. Solve for f of x is equal to 0. Well, that's where negative x squared plus 3 is equal to 0. That's going to be where negative x squared is equal to negative 3, or x squared is equal to 3, or x is equal to plus or minus the square root of 3. Those would be the two solutions, either positive square root of 3 or negative square root of 3. That's where f of x is equal to 0. Where g of x is equal to 0, that's where the set of directions, 3x plus 3, is equal to 0. What number does that? Well, the number that does that is 1. So where x is equal to 1, that's where g of x is equal to 0. Then, where f of x is equal to g of x, that's where negative x squared plus 3 is equal to negative 3x plus 3. If I get everything on one side, maybe I'll move all this over to there. So we're going to get 0 is equal to x squared minus 3x, subtracting 3 from both sides being 0. So 0 is equal to x times x minus 3, or x is equal to 0, or x minus 3 can be equal to 0. In this case, I get our two answers, 0 and 3. Those are the two places where those are equal. So we get our two solutions, x equals 0, x equals 3. On MyMathLab, all you have to do is enter those two answers separated by a comma. Then solve where f of x is greater than or equal to 0. Well, we already in part 1 figured out where it is 0. So we know on a graph, if we were to graph this, at negative square root of 3 and positive square root of 3, this graph hits 0. So it's neither up nor down. If I look here at this original function, it's a function that is negative x squared. So this negative x squared plus 3, if I put it down here so I can see it easier, this is a negative. It's a parabola that's going to be pointing down. Where are the outputs bigger than 0? Right in this area here. So where it's greater than or equal to 0, from negative square root of 3 inclusive, so including negative square root of 3, up to square root of 3, because we have greater than or equal to. Using these same sets of problems, solve where g of x is less than or equal to 0. Well, that is, we already figured out where it's equal to 0. So in this part, we found that it's equal to 0 at x equals 1. On a graph, when x is 1, this is going to be 0. It's neither up nor down. That's when negative 3x plus 3 is equal to 0. Well, is it, what is this exactly? This is a line. It's got a negative slope, so it's going to be going down. It's going to be going like that. Has a y-intercept of 3. When is this less than or equal to 0? In this range down here. This range down here happens, so this is 1, 0. Anytime the x's are greater than or equal to 1 up to infinity. So anytime the x's are greater than or equal to 1 and up to infinity. Solve where f of x is greater than g of x. If I go back, I figured out where they're equal. They're equal at 0 and 3. So I know on a graph that they are going to be crossing at 0 and at 3. I know that's where they're going to be crossing. Well, how do I figure out where they're greater? This started off as f of x, which is negative x squared, plus 3 is greater than negative 3x plus 3. I got everything onto one side. 0 is greater than x squared minus 3x. I ended up with that at some point. When I look at this, this is a parabola. The two intercepts are going to be, we already found them from before, they are at 0 and 3. That's this spot there. This spot there, that's where this graph is going to cross 0. It's a parabola. It's a parabola that's facing up. And at this part of the problem, I want to know when that parabola is less than 0, or where it's down here. And that happens from the interval from 0 up to 3. Now realize that this particular graph doesn't necessarily show what this is doing. It just shows what this parabola is doing. But this parabola came from this inequality right here. This inequality, negative x squared plus 3, is greater than negative 3x plus 3. Well, if I do negative x squared plus 3 in black, that's a parabola that's upside down, faces down, shifted up 3 units, which is going to look something like that. And then if I do the other one, let's say I do the other one in red, so I do this one in red, this one here is going to go, it's a line that goes something like this. So when is the black bigger than the red? Well, it's in this section right here. And this section right here goes from this same interval, from 0 up to 3. So left to right, it goes from 0 up to 3. We end up with the same interval from something that looks a little bit different. But we have the same interval because we still followed the rules and arrived at the same place. So either way, we get to the same spot. Solve where f of x is greater than or equal to 1. That's where negative x squared plus 3 is greater than or equal to 1. Or when negative x squared plus 2 is greater than or equal to 0. If I solve for x to figure out where it's actually equal to 0, I'd have negative x squared is greater or is equal to negative 2, x squared is equal to 2, x is equal to plus or minus the square root of 2. There, on a graph, that would be negative square root of 2, positive square root of 2. If I look at this right here, that's a upside down parabola because of the negative. So it's going to go upside down. Where is it bigger than 0? It's bigger than 0 than this interval right there. So the solution set would be from negative square root of 2 up to positive square root of 2. Now again, this graph doesn't necessarily, it comes from this, it doesn't exactly represent this, but it's a step in the process. So this right here, where negative x squared plus 3 is greater than or equal to 1, what those two things are showing is we have a graph negative x squared plus 3, which is right there, something like that, and then the graph of 1, if I put that one back into black, so the graph of 1 would be this right here. Where is this bigger than the one in black? Well, it's in this interval right here, which is going to be the exact same interval as this there. So those 2 points where it intersects are these 2 points right here. They're the exact same points. Doing some more practice with this, I suppose just for more practice, we solve for f of x is equal to 0, so that's where x squared minus 2x plus 1 is equal to 0. X minus 1 times x minus 1 is equal to 0. So x is going to equal 1. That's where this is equal to 0. Take note, on MyMathLab, all you have to do is enter the 1. That's all you're going to have to enter. Solve g of x is equal to 0. So that's where negative x squared plus 1 is equal to 0, or where negative x squared is equal to negative 1, or x squared is equal to 1. So in this case, x is equal to plus or minus the square root of 1, which is plus or minus 1. 2 answers there. We have negative 1 and 1 are the 2 answers you'll enter in MyMathLab. Just the negative 1 and the 1. Solve where f of x is equal to g of x. Well, that's where x squared minus 2x plus 1 is equal to negative x squared plus 1. So if I get everything on the same side, add x squared to both sides, add x squared, I'm going to get 2x squared, and then subtract 1, minus 2x, 0 is equal to 0, 0, 0. So here 2x times x minus 1 is equal to 0. Either 2x is equal to 0 or x minus 1 is equal to 0. In this case x is 0, or x is equal to 1. Those are the two solutions. Again, take note, all you have to enter in MyMathLab is a 0 and a 1. Then solve where f of x is greater than or equal to 0. That's where x squared minus 2x plus 1 is greater than or equal to 0. Well, you already found out where it's equal to 0. That's right here. So we know graphically that this equation is equal to 0 when x is 1. But that's the only point where it's equal to 0, which must mean if this is the only point where it touches the x-axis, this must be a vertex, and it's pointing up. So it's pointing up like that, the parabola. It only touches the x-axis once, so it must be a vertex, which means that this is bigger than 0 or equal to 0 everywhere. And what that means is our interval that it's greater than or equal to 0 is from negative infinity up to positive infinity. So doing a little bit more of this, solve where g of x is less than or equal to 0. Well, if we think back, we already solved where g of x is equal to 0. It's at negative 1 and positive 1. So where this is equal to 0 is at negative 1 and positive 1. G of x is negative x squared plus 1. This right here is a parabola that's opening down, so it's something like this. It is less than 0 when the outputs are either here or the outputs are here. To get those outputs, our inputs would be anywhere from negative infinity, so from left to right, the negative infinity up to negative 1, or jump over this interval, then we're in the interval from 1 to positive infinity. Solve where f of x is greater than g of x. Well, I already know where they're equal, they're equivalent at 0 and 1. So on a graph, they're equivalent at 0 and 1, 0 and 1, like that. That came from solving this right here, x squared minus 2x plus 1 is greater than, or came from when we solved when it was equal, thinking of that like equal, negative x squared plus 1. And when I got everything to one side, that was 2x squared minus 2x is greater than 0. Well, this right here, this is the parabola that's going to be facing up. So it's a parabola that goes up like that. And where it's greater than 0 is on this interval and that interval, which goes from negative infinity for inputs up to 0, or from 1 up to positive infinity. If I wanted to check to make sure that that was actually true or that was actually the case, I would check it with a number. So let's say I check it with 1/2, because 1/2 is between here. 1/2 should not work. So if I check with 1/2, this should not work because it's not in the interval that I actually shaded or chose. Well, let's see once. If we take 1/2 squared minus 2 times 1/2 plus 1, we'd have a fourth, minus 1 plus 1, which is a fourth. If, on the other hand, we put it into g of x, we take negative, and then 1/2 squared plus 1, we'd have negative 1/4 plus 1, which is 3/4. Well, is 1/4 greater than 3/4? No, it's not. And that's good, because that shouldn't have worked. That was in an interval we did not choose. Then solve for where f of x is greater than or equal to 1. That's where x squared minus 2x plus 1 is greater than or equal to 1. Or if we solve for 0, get 0 on that side where x squared minus 2x is greater than or equal to 0, subtracting 1 from both sides. So where x times x minus 2 is greater than or equal to 0, which is where x equals 0, or x minus 2 equals 0. So x is equal to 0, or x is equal to positive 2. Those 2 points are where it's actually going to be equal. So it's equal at 0 and at 2, which, if I look at this part right here, that would be from a parabola that goes like this. Excuse me. This parabola opens up, so it's a parabola that opens up. Where's this parabola greater than or equal to 0? Well, that's on this interval or this interval. So it goes from negative infinity up to 0 inclusive, because we have greater than or equal to. And what I'm realizing is, I'm thinking about it, I got a little sloppy. Here we had less than or equal to, so I should have included those. Here, or down here from 2 up to positive infinity. If I look back, did I mess those signs up anywhere else? Here, no, because we have infinities. Here, no, no, no. So, looks like this here, which one? This one right here was the only one I messed up. So, this would be the solution for this one down here. I believe that's it. If nothing else, that face should make you smile. Good luck. Let me know if you have questions.